I do agree. SQL is being used in a lot of places. You cannot run away from it. In fact, it's like Mongo is like fairly useless. If I'm being, I wouldn't call it useless, but like definitely not being used in projects, which is why it made a lot of sense for us to have this class. And with that, let's do it. Let's get started. Hi everyone, welcome to week 13 now. So it's almost been 3 months and we've done the basics. We've done, I would say, moderate level. There are a few things that are not part of the MERN stack, but are the things that are being used, which is what we will cover now. The thing that we're covering today are general SQL database, more specifically Postgres, the one that's being used everywhere. And this thing called a Prisma ORM. ORMs and Prisma we will cover tomorrow. Today's class is just introduction to SQL, Postgres, writing Postgres queries, some advanced things like what are joins, what are indexes, and how you used to write data before, or like write to databases before ORMs came into the picture. There aren't any prerequisites. You don't need to know React for this class. You need to know a little bit of backend, a little bit of Node.js. But if you're in the lot who's still struggling with React, this class shouldn't be too difficult. Forget all the React stuff, maybe all the front end stuff, and this class just focus on databases, more specifically SQL databases, and how you can connect them to your Node.js backend. All right. This might seem very similar to what we've done in the past, which is MongoDB, only like some queries change, how things are stored change, but at a high level, shouldn't be too difficult of a class and shouldn't be overwhelming, is what I feel. All right. Let's get right into it. Databases are of many types. Two famous ones are these things called NoSQL databases and SQL databases. I think a lot of you already know this from like my high level understanding. If you've done basic backend in the past, you've interacted with one of these. If you've written the to-do application, we've been writing data in MongoDB. Now there is a very high level difference between these two types of databases. SQL was the popular choice. NoSQL came like a very new entrant a few years ago. Sort of became popular, especially with MongoDB and a bunch of other databases. And now there's like a decent battle between these two. Okay, which one is the better one to choose? What should projects use? For us, Backpack uses Postgres. Cal.com I think uses an SQL database. Unsure if it's Postgres or MySQL. Dub.sh, the open source project I've been telling you about, uses MySQL. So what's being used everywhere is usually SQL, and there are reasons for it, which we will discuss very soon. At a high level, the biggest difference between them is SQL has extremely what's called a strict schema, which means your tables in your database need to be very strictly defined upfront. Our user's database needs to have a first name field, a last name field, and a password field, for example. And NoSQL databases are schema-less, which means you put whatever you want. You want to put username, okay. You want to put another field called email, you put. Without telling that upfront in a place, without telling upfront what a table should look like, you can put any data there. That's why it's called schema-less, because there is no schema that you have to tell about upfront. This is much faster to use in production applications because, as I said, when you're creating an SQL database, you have to tell a bunch of things upfront. Okay, this is what my tables look like. If you ever want to change your database in the future, let's say add another field here called first name and last name. Let's say this is the user's table. And initially it only had username and password. Eventually you have to add first name, last name here. Then you have to do something called like add migrations, tell to SQL, your database, hey, this is the new database structure, please change it. All these things you have to do. So for hackathons, NoSQL databases, MongoDB is a better choice usually. And that's why people who've done this are sort of scared of this, because this seems like a lot of boilerplate code to add, understanding how SQL queries are written, versus here it's just like do a function call and you're good to go. So that's why people don't like this, similar to how people don't like moving to TypeScript from JavaScript, but that is necessary, similar to why this is necessary and why this is used in production everywhere. Okay, so we need to understand SQL. This is the high level difference between SQL and NoSQL databases. Let's move on. This is at a high level what an SQL database looks like. MongoDB database looks something like this, which is like username, password, and you can put arrays here as fields. You can put objects. SQL, however, is simply a table which has a bunch of rows. Each row can be a number, a string can have columns which can be a number, a string, whatever. You can put objects here as well. So I can add like something like addresses here and add like an object as a column field. It's not recommended, and it becomes harder and harder to do something called like searching. If you want to search everyone in Chandigarh, it will be harder to do if you shove it down here in the same table, the users table. You can do it in SQL. You can also do search in SQL. Sorry, NoSQL. If you use a NoSQL database, put everything in a single table. That's fine. First name, last name, address. You want to search by state Punjab, you will be able to. In SQL, if you do the same thing, you create a field here called address, which just shoves down the whole address object. It will be harder to do searches and generally is not recommended / used / something you should do. You should always do something which is called normalizing into other databases, which is what I've shown here. So if you want to have a users table and you want to store their addresses as well, all the addresses will be part of another table. You will have a users table. It will have the basic fields like first name, last name, whatever is a string is a number, age, date of birth, fine. If you want a more complex object, you will either need to put 10 different fields here. For example, address 1, city, state, country. You can either do that, or generally you normalize your database, which means you break it down into smaller sub databases, which are somehow related. That's one very important concept in SQL, this thing called relationships, which is you break down your data into multiple tables and these tables are somehow related with each other. For example, the address table is related to the users table. If you want to create like a basic application in which you want to store the users metadata, their name, their date of birth and their address, and let's say the user could have multiple addresses, then this is the way to go. You have two different tables. The user table looks fairly straightforward. The user has an ID which is unique, a password, a first name, last name, maybe an email field. The address table has the normal fields, which is the address, city, state, country, but has one extra field here called user ID, which is how this field relates to something here. This is what's a relationship. You can totally omit this user ID field and merge both of these tables and be like there's a single table which is users with addresses, but you don't do that usually. Why? What if the user has two addresses? Will you create two entries in the two data in like the users table? You don't want that, right? You want a single entry for a user in a users table. If they could have multiple addresses, you will have to put it either in a single very big object here, which is something we don't want. So you put it in a different table and you relate this table to this by putting a new field there called user ID. If I ever want to know all the addresses for the user with user ID 1, I can go through this table and search whoever has user ID 1, give me all the rows for it and I'll get all the addresses. Is this part already something we knew, straightforward, already done, or like basic stuff? Or is this also fairly difficult, the things I've taught until now? Okay. 93% are good. So yeah, this is like fairly straightforward, basic SQL stuff. Any sort of repository you go, any YouTube video to go through, you can sort of understand this part. It's fairly straightforward of how it looks. Now let's dive deeper into how you can use an SQL database in your Node.js application. Before that, there are many famous SQL databases. SQL stands for Structure Query Language. It is how you query a database or basically ask it for data, put data inside. A lot of people have created their own versions of databases that can understand SQL. So Postgres is one famous one. MySQL is another famous one. There are a bunch of others. These are the two that are mostly used. Postgres is what we're learning today. All right. Let's understand how you connect to a Postgres database. Maybe before that, let's understand how do you create a Postgres database. I hope a few of you have created MongoDB databases in the past because we've created a bunch of backend applications using it. This is how you connect to a MongoDB database. And this is how the sort of URL, this is how the URL looks like. This URL has their username, a password, and a link to connect to it. And this is the specific sort of database that you're trying to connect to. This is how a MongoDB string looks like if you're trying to connect to a MongoDB database. Similarly, if you're trying to connect to a Postgres database, this is how the string usually looks like. Starts with the protocol, which is Postgres : // Then there is a username : there is the password for your database, at the host, the specific EC2 instance where it is hosted, or if you're using some third-party service, then URL to that. If you're using your own server, then this is replaced by localhost / the name of the database. This is a high level of how a Postgres URL looks like. How do you start a Postgres database server? There are many ways. You can do it locally if you want to. I have not covered that. We will cover all of that after containerization, because there are easy ways to run Postgres locally, MySQL, MongoDB locally. If you know containerization, you can run them in a containerized fashion, like one line of code. Right now, you can do one of two things. I did mention this on Discord yesterday. You can either go to Elephant SQL and get a free MongoDB database. It's very small, only 20 MB of data it allows, but we won't need more than that today. I have already done it. I would urge you to do it as well. So if I go to list all instances here, as you can see, I have a test Postgres instance running. I will give you guys 2 minutes for the people who haven't done it. Go to elephantsql.com and try signing up and creating a instance for yourself. This is similar to when you went to the MongoDB website and created an instance for yourself. All right, 2 minutes start now. Once you do, it will look sort of something like this, and here is where you'll get like your long URL, which you can use to connect to this database. What they're doing is starting a very small Postgres instance for you, or a shared instance most probably, since it's free, which means there's a single server where they're running small Postgreses. All of us will be using that, and each one of us has our own database. So I have my WZSSG, whatever is my database name. You will get a random one. When you're running this locally yourself, or if you deploy it on your own, you can decide the database name, the password, the username. If you're using Elephant SQL, they will give you sort of a password username that you have to work with for now. All right. So this is the high level structure. This is how my URL looks like. The free URL that I got from Elephant SQL. Going to wait for 1 more minute and then we will proceed. Please create an SQL, a Postgres database for yourself, so you can practice along when we're sort of going through the assignment. Till then, maybe I'll look at Q&A. Companies, it's very finicky. It just depends on the CTO, whatever they want. So sometimes they're like, oh, whatever they usually have experience with. Postgres, I'm seeing sort of taking over. So Zerodha uses Postgres for their main database, like their trading database. So good big applications use Postgres. Some good ones use MySQL as well. These are the two popular ones. MongoDB is like barely used. All right, 30 more seconds and then we proceed. Alrighty. Cool. So you have a database. We had databases in the past like Mongo. What does a database allow you to do? What is the purpose of a database? Let's quickly revise. If this is the user's browser where the React application runs, or more specifically HTML, CSS, JavaScript, this is the Node.js process that the user hits through HTTP APIs. We initially were storing data right here itself in the file system in memory. Eventually realized the Node.js process isn't supposed to do that. There are specific things called databases that are supposed to do it. And usually your Node.js process is calling 4 types of queries on a database. A query to insert some data, insert users, insert to-dos for a to-do application, update data, get data, and delete data. These are the 4 high-level queries, or 4 things that you need a database for. What is this? Could be Postgres, could be MySQL, could be MongoDB. The high-level goal is the Node.js process wants to be what's called stateless, which means it doesn't want to store any state here. This is not the React state. This is state like the number of users that you have, or the list of all the users that you have, or all the to-dos. You don't want to be storing that in memory because your process crashes, it goes away. Your server dies, it goes away. You really need to be dependent on something else, which is what's a database. We've done many. We're learning a new one today, which is the Postgres database. These are the 4 queries we expect it to be able to run and like give us data, let us update data, things like these. All right. Hopefully this is straightforward. Let's learn by doing, because I can keep talking, but there are 1,000 tutorials out there. If you don't code yourself, you will not learn anything. So we will please clone this repo, the week 3 SQL repo, where we have a bunch of SQL that we have to cover today. Yeah, please try to clone this. We will try to go through this sort of quickly because it's fairly straightforward stuff. Especially if you've done MongoDB in the past, or like we've done all the assignments until now, or not the assignments, like basic to-do app you've created, it'll be very straightforward as to how you do this in SQL. So please clone this repository locally. I have just posted it in chat. It's present at 100x devs-hkirath, what do you call it, GitHub repository. It's at the very top. If you go there, you can either download zip and open it in VS Code, or you can go down the Git route, clone it, and all that jazz. I'm going to give you guys 30 seconds to do it. And until then, I am going to do the same thing. 9. Looking at Q&A until then. Please give assignment this week. I will give assignment today. In fact, you take it right now so that I don't, even if I forget. The assignment will be, you will have to create a database, put like 1 million entries there, or maybe 10 million, do queries on it, query it based on a specific query. For example, give me all the to-dos for a user, and then fill the to-dos table with 1 million rows, then add indexes to it, and then see if your the speed of your sort of query goes up. And you basically have to create metrics on how much time does it take to get all the to-dos for a user, if the database is indexed or if it is not indexed. So that is a good assignment to do. But there is some caveats there in Postgres, so stick through the end of the assignment, the class, and then you'll understand that may not give you the results that you would be hoping for, because Postgres does a few things. So yeah, that's like one assignment I can definitely give this week. All right. So if you guys might have remembered this thing called Mongoose we used for connecting to MongoDB. Today we are using a similar package. Now databases also expose sort of a protocol similar to how we expose the HTTP protocol, and your backend server needs to talk to the database using that protocol. You can write that from scratch if you want, but you can use tools like Mongoose, the thing that we've learned used in the past, or the thing that we're using today is the PG library, which is a Postgres client in Node.js. Basically lets you connect to a Postgres database and send it these 4 types of queries: the update query, insert query, all that jazz. You don't have to specifically add this. I have already created the project, so you don't have to create an empty project. You can just clone this project and run it locally, because there are a lot of queries to go through. If you can write them from scratch, but then the class will be really slow. So maybe after the class, feel free to write these yourself. Right now, just clone the repo, and all you have to do here is either npm install or yarn install, and it will install all the dependencies. If you look at the dependencies, you will see pg and @types/pg here, which is the library that we're using to connect to Postgres. All right, cool. Hoping most of you have done this. Going to proceed. So what are we creating? We are creating the database part for our to-do application. If you remember, to-do application has 2 parts. One, you need to store all the user information. When the user comes to your application, they sign up with, let's say, just the user email and password. So no need to store first name, last name, very simple. And to-dos, they give us a title, a description of a to-do. We store that in the database, and there is a field there called done, which means whether or not this to-do is done. As the user is able to do the to-do, they select a checkbox, click a button on the website, and then we update the database to set done to true. So this is what our database should eventually look like. This might feel weird, but this is similar to how in Mongoose we explore data like this, right? Which one of these is the right one? This one. So if you remember Mongoose, in Mongoose, our to-do application, this probably isn't the right database, but this is how you store data in MongoDB. Email, password, this is how you can visualize data. If we do the same thing, again, this Mongoose client won't be able to connect to it. There are other ways for you to see the SQL data on your machine, other like GUI tools like this. Finally, when you do see it, we should have 2 tables, the users table and the to-dos table, where the users table should look something like this. The to-dos table should look something like this. We're going to see how we do that very soon. Let me quickly do a poll just to understand the pace is decent or not. %, good to go. All right, so this is what a database will look like. Let's see how we can do this in SQL. What are the constructs that we need? First thing we need is we need to understand, again, we need to tell Postgres this is what our database looks like. This is the biggest difference between SQL and NoSQL databases. Before you're even starting to write your application, you have to tell Postgres that, hey, this is a new table. This is what it looks like. This is starkly different from Mongo, where we would just put data in a database and it would automatically create it. And it never worried about the schema. Whatever you want to put there, it let you put here. In case of SQL, you have to tell, these are my fields. These are what they look like. And before you do any insert operations, or get operations, update operations, you need to tell Postgres, this is the schema of my database, and this is the query you have to run to do it. What are queries? How do you run them? We'll come to very soon. So the query or like the command that you have to run looks something like this: create table users. This is like a language in itself, the structured query language, or SQL. This is the syntax for that language. This is how you tell SQL ke create a new table called users. Let's look at what are the fields here. It says there need to be 3 fields: ID, email, and password. ID is serial. That means keep increasing it by 1, 2, 3, 4, 5 like that. Create it automatically. And it should be a primary key. What this means is, whenever I do an insert operation, I can simply say create a new user with this email and this password, and an ID will be automatically generated for them, and it will start from 1 and keep going up 1, 2, 3, 4, 5, 6 like that, which is why finally our table looks something like this. 1, I deleted the user 2, but 3, 4, 5, these are the automatically generated IDs that are given to the user. That's what the first field means. You will see this very often in SQL databases, or like specifically when you're creating tables. Okay, this is how you give a unique ID to every row of your inside your table. That's what primary key means here. It means this is the primary key of this table, which means this will always be unique. This is how you can identify a user in this table. There can be 2 users who have the same ideally there shouldn't be, but let's say there can be 2 users who have the same email as well, but their IDs can never be the same. SQL will sort of complain. It won't let you put 2 users with the same query in there, same ID in there, which is why, which is sort of what primary key means, or like the purpose of primary key. Okay, this is how you uniquely identify a row in this specific table. All right. Email, varchar 255 basically means text, or you can think of it as strings. There are multiple sort of ways you can create strings in Postgres or MySQL, sorry. This is the most popular one, which is varchar, like a variable character of length 255 characters, which means if you send a very long string, it will fail. But the assumption is that the password and the username will not be more than 255 characters for the user. Unique, which means email also is unique. So this will also be unique. Since we added unique here, email will also be unique. If I don't add this, we could put into the same database 2 rows with the same email. We don't want that. Emails are usually unique. When you sign up on a website, whenever you try to sign up again, it says, oh, you already have an account. We want to support something like that. We don't want to be able to ever put 2 users with different IDs, but the same email, which is why you just mention unique here. And then Postgres takes care of. If you ever try to do an insert with the same email ID, it won't let you. That's all you have to do as the application developer, is mention unique and not null, because you never want to put an entry into the database where the email is empty. Email should always be present. Password should also always be present, which is why email unique, not null, password not null. 2 people can have the same password. They cannot have the same email. There are some nuances here. Passwords shouldn't be stored in plain text, and you should hash them. And when you hash them, they are usually unique. But for now, we are storing the passwords in plain text, which means if someone has password 1, it gets stored as such in our database, and it is fine. 2-3 people can have different. So it's the same password, which is why password is not unique, but email is unique. All right. The things that we have learned here in this specific sort of create table users query. 1, serial primary key, something you will see very often. What it means: anytime there is an entry done to the database, give a primary key to this specific row, which is just increasing serially 1 by 1, starting from 1. 2, varchar, which is 1 type. There is also integers, boolean, things like these. We only have to worry about strings for now. Varchar is like just one way to write or tell this is a string in the database. Unique, which means this row is unique, and not null, which means there needs to be at least 1 digit, 1 letter there, else SQL won't let you put an entry, which makes sense for the users table. All right, let's proceed. The other table that we need to create is the to-dos table. Very similar. ID, serial, primary key. Here we will put all the to-dos for a user. The title, which is, so you can use text here as well. You can use varchar. Text, I think, has no limit to how long it can be. Varchar has some limit, and there's like some nuances to the difference between these two. You can use either. Description, which is also text, which can be really long. Let's focus on this first. Done boolean default false. So one new thing we have learned here is default X, which means even if when the user is doing the insert query, if they don't give you done by default, you will default it to false. So there will always be some value there. So you can also do done boolean not null default false, because if it you're trying to put null there, it will default it to false most probably, or maybe that complains as well. So don't quote me on that, but you can be for sure. You can always be sure if you're putting in an entry in the database into the to-dos table with a title and the description, done will default to false unless you have explicitly given it true. The reason for this is whenever the user is creating a to-do, they will only give us title and description. We will forward it to the database. And of course, if the user has just created a to-do, they haven't done the to-do, they haven't completed it, which is why we can just default it to false. All right, that's the purpose of default. Finally, this is a new sort of row here, which I've been talking about, which is the relationships. Okay, this is all fine, this is fine, but we want, we need to be able to tell which user does this to-do belong to. A to-do can belong to only one user, right? We know one to-do cannot belong to multiple users. I will create a to-do, it will go into the database for me. Someone else creates theirs, even if the title and description are the same, that's their to-do. That should be stored separately into the database. So we need to be able to relate these to-dos. If I go back a few slides, you will see, I told you guys that there are relationships in SQL databases. If there are two databases, bunch of times you will see this guy is related to this guy, and there's this user ID field that relates this to this. This is what is called a foreign key. What this means is addresses has a foreign key to users. So every entry here, every row here will have a corresponding user here. You need to make sure that is the case. There should never be a to-do or never be an address that doesn't have a corresponding user. That means there's a fault in your application logic. Never should there be the case there is an address entry for an unknown user. Never should there be a case there's a to-do entry for a user that doesn't exist. The way to sort of harden this in SQL is this right here, which is user ID integer. So integer is another field that comes now that we have introduced here. References users of ID, which means this guy is a foreign key to the users table ID. In the users table, there is an ID, which is serial primary key, means it's an integer. This table, the to-dos table, has a corresponding user. For every row has a corresponding user. And this user ID is what relates to the ID field for that user. Is this part clear? This is probably the only thing that will woggle a little bit, and then maybe joins, but everything else should be straightforward. So is this part clear? Foreign keys, basically a high level of foreign keys. Is this clear? Oh, foreign keys are deleted. Oh, it's clear. All right. So 86%, which is not bad. I will give one last explanation for this, then we will proceed. The explanation is SQL and NoSQL are significantly different in the sense you can shove all the data of the user in a single place in NoSQL. If you go to NoSQL databases, look at this. I said this is the user. Let's say this was addresses was an array. I put 10 addresses here. You can shove all of it into a single table. You can, but you should not do that in SQL databases. You should separate the data out into multiple tables. This is table 1, this is table 2. This table will now have 5 entries. So similar to how you would store an array here, you would store 5 entries in the addresses table, and each of these entries will be related to the user through what's called a foreign key, which says that user ID here represents a user here. So whenever you want to find all the addresses for a user, in the NoSQL world, you would simply say, give me this user's entry in the database. In the SQL world, you will say, bro, just look at the addresses table and find all the entries where the user ID is, let's say 1. That's how you know all the addresses for a user with a specific user ID in the SQL world. So SQL always separates data out into multiple tables, and they are somehow related. In NoSQL, you shove it in the same sort of database or the same table. So this is a high level difference that will come in the future as well. And foreign keys are one concept you need to sort of understand a little bit. If foreign keys are given a table, how is it related to another table? These get more and more complicated as time goes by. This is a very simple use case with single foreign key. In the future, you might see multiple rows which are related to like multiple tables, and things get more complicated. All right. So let's try to run this locally. Let's try to create these tables in our Postgres Elephant DB SQL thingy. So now I would urge you to go to Elephant SQL website, get your Postgres URL, and please make sure you replace it here, else we will all be writing to the same sort of database. So please replace this utils.ts with your own Postgres URL. If you use mine, then we'll all be writing to the same database. It'll just get confusing. We might fill up our database. It's a free database that I'm using as well. So please replace this with your own database and only then run queries locally. If you don't yet have a database, feel free to run it on this. It'll just create problems in the class because we'll all be conflicting. So I'd rather urge you guys to either not run or run this on your own sort of Postgres instance. All right, cool. So quickly going to show you something which you don't have to know or have on your machine right now. Just how we had Mongoose that would let you, MongoDB Compass, this sort of GUI that would let you connect to MongoDB instances. There is a CLI, which is like command line interface, that lets you connect to Postgres instances. You don't have to have this locally. I'm just going to show you what this looks like. It's called PSQL, and this is the sort of command that you have to give: the host, the port, the username, the database, and then I have to just write the password here, which is this thing right here. And it lets me sort of connect to the Postgres database. I can send queries here. For example, /dt gives me all the tables that currently exist. I just want to delete all the tables so we can sort of run all of these again. So drop table sort of lets you delete a table. You don't have to do any of this because your database will already be empty. Mine isn't. All right. Cool. The command that I showed you, the create table command, I can run here or I can run via Node.js. I'm going to run via Node.js, but you can always just run SQL queries here. It will forward it to your database and it will like create the respective table there. But we're not going to do this here. We are going to do this in Node.js. How? I told you about this library called PG. This lets you sort of connect to Postgres databases and run SQL queries there. So for now, you just have to focus on two files, the utils.ts file and the create-table.ts file. Util.ts file has this high level function that gives you a client from this Postgres class where it has the URL to connect to. You call connect, it awaits it, it creates a connection to Postgres and finally returns you the client. So I just encapsulated this into a single file so that all the other files where we're going to run various SQL queries can use it. All right. So utils.ts, fairly straightforward. It has a get client function that gives you a Postgres client on which you can finally call some functions to actually send your SQL queries to your Postgres server. Let's look at what that looks like. If you go to create table.ts, you will see I have a variable here called create user table query. It has the same query that I showed you in the slides a few minutes ago. Create table users, ID, serial primary key, email and password. Then I get the client using const client equal to await get client. Let me just put it here. And then I do client.query this. So this is all you have to do, client.query. To forward this query to the Postgres server, you could also totally run this in the PSQL. So I can just copy this and run it here after I had the PSQL CLI running. Or I can use this client which uses PG, the NPM library internally, to send this query to Postgres. Both work. So I've created this query 1, this query 2 to create the tables in my Postgres database. Again, this is something you have to do if you're using Postgres. In Mongoose, you don't have to worry about it. You don't even have to ever create the tables explicitly. It automatically creates them when you do the first insert query. This guy does not, because this guy needs to know what the structure of the table looks like, which is what we're telling it here. Ki bhai, create two tables, to-dos and users. And then we use client.query to send these commands to the Postgres server. All right. Try to just marinate this from top to bottom here. feel free to take get client as a black box as well. You can think of this as a library that I have created that gives you connection to my database. Hopefully you have replaced the URL here with your own Postgres URL. If not, also it's fine. It'll just create some problems in the class, which is fine. Cool. Query 1 written in literally plain text. What is this, Harkirat? This is just tilde. It lets you write like strings in multiple lines. You can also do something like this if you want. Put them in the single line like this. Both work, but like this one's just cleaner, which is why I've used this. Where is this, Harkirat? On your keyboard, it's right above the tab key, and that's how you sort of get this character. All right. Nothing special here. It's just a string. You could also write this. All right. Don't think like this gives you some special powers. This is just a string, and then we just send the string to the backend, similar to how we would send the string here in PSQL. All right, let's try to run this. npm run build, yarn build, whatever you're comfortable with by this point. After you've built it, node dist/create tables.js. Tables created successfully, which means this command ran, and then finally this was logged. Let's see if that actually happened. I can connect to my database using PSQL and check it out. Even if you cannot, it's fine. As long as you see this log, it means your table was created. If you see some error, that means there's some problem. Most probably in the URL that you're sort of writing in this file right here, the utils file. All right, cool. Let me quickly show you guys that the databases have actually been created. If I type /dt here, I see that two tables were created. Sorry, not databases. Two tables were created, the to-dos table and the users table, and their schema looks something like this for now, for both of them. This guy's schema looks like this guy's schema looks like this. Straightforward. Shall we proceed? Oh wow, 80%. It's like okay. What is the question for the 10-20%? Sorry, where are we stuck? Are you just not able to do it or something like that? Chat is open. Oh, cannot find module create table.js. Did you run npm run build? If you did not run, if you ran npm run build, did it succeed? If it succeeded, is the dist folder created? Npm run build, you should see the dist folder getting created here. If not, then there's some error with your code basically. Recap, I will do that suggestion. We should create a singleton for we should, but let's focus on the basics right now. There's no structure in SQL. Why do we create models? So you do create models, but models are like client side, which means they're on here. You can still, without like update the model and send data, you can from other place without a model send data and update data. Your Mongo doesn't have any constraints. You can put constraints here कि हाँ भाई don't send the wrong data from your Node.js backend, but Mongo has no constraints on itself. If you change it, it will change on the MongoDB server. Here SQL has constraints. Whatever you send it, it will be like, bro, it should follow like this. Some people ask for recaps. Let me do a recap really quick. We are learning about a new database called SQL databases. Very different from NoSQL databases. What are NoSQL? MongoDB, the thing we've done until now. Big difference between them is this guy has a very strict schema that you need to tell upfront when you are creating the tables in your database. All right. What's the way to do it? This is the way to just create the tables. We haven't yet put any data. We're just telling it the structure of our data. Okay, hello Postgres database. This is the structure of our data. There should be a users table, looks something like this. There should be a to-dos table, looks something like this. That's what. That's how you define the schema of your table or like your database, and you tell it to Postgres, so this is what my database looks like. This is something you need to do. This is what we have done until now. Nothing else we have done. No application logic we've written, and like we have not yet put data there. Don't worry if you don't yet are able to do PSQL locally. It's fine as long as you're able to run and do node dist/this thing. It should work. If this is giving you an issue, make sure dist is actually created. If dist isn't created, please run npm run build first. If npm run build isn't working, make sure you're in the right folder, all the standard things. Make sure you have done npm install, basic things, hopefully. Make sure you're like able to debug this locally. For example, someone I saw, the error was that the dist folder wasn't created. So most probably you need to run npm run build locally. All right. With that recap, how are we doing? It's like not able to run but understand, or able to run locally. All right, so a lot of times recap is all that's needed. Cool. 87%. So good to go. Let's proceed. 4 things we need to do: insert data, get data, update data, delete data. Let's pick them up one by one. Let's go to the slides. Inserts. This is how you put data in an SQL database. Again, this is the raw SQL query. As we move to ORMs, life will become easier. Until we move there, we have to write code something like this. Insert into to-dos. This is the name of the table. The columns that you want to insert: title, description, user ID, done. You don't have to send done, but if you want to send done, feel free to. Values: the title, the description, the user ID that you want to insert for, and the done value. Similarly, insert into users, username, email, password, and then this value. If you try to insert a to-do and you put a user ID here, that does not exist in the users table. This will complain because this has a very strict schema that every entry here for user ID should have an entry in the users table. So if you're doing an insert, it won't let you do an insert unless there is an entry in the users table. Similarly, if you try to delete a user who has a bunch of to-dos, it will complain. It will say, bhai, there are some to-dos already for this user. First delete those to-dos, only then can you delete the user. That is the benefit that this references things gives you. Okay, you cannot violate this constraint. If you delete a user, it will first tell you, please delete all the to-dos. If you try to insert a to-do which does not exist for a user, or a user does not exist, you put some random ID here, it will complain. Okay, that's the high level thing to know. Other than that, this is what the query looks like. Just like create table query, this is insert into to-dos, the columns, and then the values. Again, I can run this either on using PSQL here, or ideally, you should ideally run it using the insert-data.ts file. So let's try to look at what this says. There is a create entries function here. At the top, we get the client. Again, the code that's abstracted and put in one place. I get the client. This is the insert query. Insert into users, email, password, values, $1, $2 is something interesting. We'll see what that is. Returning ID, which means after this query is done, please return me the ID of the new user that is created, because we are not giving the ID up front. Let's say you need that ID for some reason. All right. You can also be like, return me email, or maybe return star, which gives you everything, but you already know the email and the password. So maybe the only thing that you might need is the ID. That's just a string stored in this variable. Second thing is user values. Ke haan bhai, this is the email that needs to be inserted. This is the password that needs to be inserted. Then again, await client.query, the text, which is the insert query, and then the values. The only sort of dumb thing that feels here is, why have we done $1, $2 here? Why can I simply not do this? And this is a bounty. I smell a bounty coming. Why do we do this? Why can't we simply do this? Why do we separate values into a separate thingy? Hands on the keyboard, $50 bounty. Who knows the answer for this? There is one very specific, biggest reason for this. What is the reason for that? There you go. Ashish wins the sort of bounty. Ashish Choksi. The answer is something called SQL injection. You can totally do this. john@gmail.com and hashed password here. The problem is, these you get from where? From your user on the front end. Your user can simply write here values john@gmail.com, whatever here, and something like some bad things here, like and drop table users. If your user goes to your website, for example, I go to whatever harkirat.classes.co.in. If they go to the sign up page and yahan pe they write harkirat : drop table users and press sign up, what will go here in the values? There will go Harkirat drop table users, which will, and then if we send this query as such to the database, it will basically drop our users table, which is not good. This is a very common vulnerability that's called SQL injection, because you're letting users inject SQL into your backend, which is why the standard sort of way to fix this is that you put these variable templates here and you say that the values for these templates are this. This way, even if the user sends you whatever drop table, this will as such get stored into the database. The email will become John Harkirat drop table. Versus if we do the other approach, the SQL query itself gets modified. But if whatever is here in these values does not get executed as SQL, basically it's upfront a value that needs to go as such into the database, versus whatever is present here, which is like if it's an email followed by a drop table, will as such go to as an SQL query, which will drop your database. So that's a high level of why you need to write such a syntax rather than, whatever putting it. There are some other benefits to it, but like the biggest benefit is this. And you'll see this standard across libraries. You don't put the data that your user provided you directly here. You separate them out into values and put like templates here. All right. Same thing we do for the to-dos table. Insert into to-dos, title, description, user ID, done. $1, $2, $3, $4. And what are the values? Let's say some random buy groceries, milk, and then, so what we are, this is an important sort of thing. Response may be said, bro, returning ID. So here you can actually get response.rows of 0.id, which is the ID of the newly created user. You also know by default it will be 1, so you can just put 1 here. But this is the way to sort of grab the ID from the original query. Okay, you said insert data, you said it should return ID. This will just return a single row. Sometimes you do SQL queries, they can return multiple rows. In our case, the 0th row of 0 will give you the new user that is created. We only asked for their ID, so we have access to the .id sort of key here. All right, and then done is false. You can also remove this because this we said by default is false, so it will just work without this as well. You can add this if need be. Finally, do the other query and then log entries created. Let's see if this works. Node dist / insert data.js. If I run this, it gives me an error. Okay, this user already exists because already someone of you might have sort of created this user and run this query. So I'm going to run it for another random email. And it says entries created. I think a few of us are now using the same database, which is totally fine. If I go to PSQL here, I see there is, oh wow, there are a few tables that have been created by a few users. So basically you guys are fiddling with it, which is fine. If I do a select star from users, so I can run like queries directly here as well. This someone else created, this I have just created. All right. Cool. Inserts we understand. Hopefully poll will tell whether or not we do. Let me show this code again. Insert data. Is this part clear? One, you don't have to understand SQL injection completely, but do you understand that this is the syntax we have to use for now? Why? There are some security reasons, and two, like how to insert data. All right. Let me do one more and then I'll do questions. We won't have a break today because I have to leave a little early. I have a flight to catch. So let me do gets and then we will do, we can do like a question session. All right. What are gets? You can insert data. You also need to fetch data eventually. When your user comes to your website, you need to get all of their to-dos. The way to do that is select the rows that you want from the table that you want. And then there's usually the where clause, because you need some specific conditions met for that, the rows that you want. For example, you might want all the to-dos for a specific user. So let's say their ID is 1, not desired user ID. Let's say their ID is 1. You can be like select star from to-dos where ID equal to 1 or like user ID equal to 1. That will give you all the to-dos for that specific user. So again, this all filtering Postgres is doing on their side, and it's just returning you the right set of rows that you need. So if I go to PSQL here, again, you don't have to do this locally. And if I run this command that I was showing, select star from to-dos where user ID equal to 1, let's say, it gives me all the to-dos for that specific user. But again, we want to run this here. So let's go to the get data query and see what it looks like. Sorry, the get data file and see what it looks like. It has two functions. The get users function. Let's say there's an admin dashboard where you want to see all of your users. For there, you need like a list of all the users. The way to get that is select star from users. You have to forward this query, get all the data from Postgres. So this is the query that you need to send. This is how you send it. This is how you get the data. And then finally, as you might remember from the last slide, User.rows gives you all the rows that have been returned, and then I just iterate over all the rows and log them here. If this syntax feels weird, you can also do like for let I equal to 0, I less than this dot length I plus plus, and log them one by one. This is just another way to iterate over an array. In the end, user res.rows is an array of a bunch of sort of entries from the users table, which has like an ID field, an email field, so on and so forth. You can specifically mention I only want email and ID. I don't want the password, let's say. Here, if you want to selectively get a few items, you can use this syntax. If you want to get everything, you can use this syntax. All right. This is how you get all the users, and this is how you get all the sort of, let's say you want to get a user from their email. You will need this in the sign up route eventually in a to-dos. Whenever the user, let's say signs up, actually you might not need this generally, but let's say there's a question. Okay, give me a user's details from their emails. The query will look very similar. It will be select star from users, but there is a where clause, where email equal to something, and then the standard way to send a query, send the text, send the value, which is email in this case, and then finally we log all the rows, which there will only be one row in this case because we have the constraint. Okay, each row needs to have a unique user. Finally, get to-dos for user, which is given a user ID, get me all of their to-dos, basically the same command I was running downstairs here in PSQL. Select star from to-dos where user ID equal to $1, and again forward this, the textual query, and then the values, and then finally log them one by one. All right. So 3 types of queries we're trying to run here: get all the users, get user from an email, get to-dos for user. These are the 3 sort of high level queries that we're running. Let's see if they actually work. So yarn build followed by node dist / get -data.js, and it gives me single user details, user ID 1, John, this, which was basically this thing right here, single user details. All the users, which is like this log from here, it gives me all the users one by one. To-dos for users with ID 1 is this specific single to-do that we have for now. If I put more to-dos, I will see more rows here. All right. You might ask, Harkirat, first get users was called, then this was called, but get users logged later, and this thing logged first. Why is that? The answer is because query, this is a bigger query, so maybe it took more time. These are all happening asynchronously. If you remember a little bit of asynchronous, if I put an await here, then they will happen sequentially. If I could, I cannot, but like if I could put awaits here, then this would first, this would run, then this would run, so on and so forth. But now these are running parallelly, sort of, and asynchronously. So get users maybe send its query. This guy also sent its query. This guy also sent its query. Whichever query returned first got logged first, which is why even though this was called later, it logged first. This was called first, it logged later. Hopefully this is straightforward. Not straightforward, but like easy to understand maybe. So these are the 3. This is the most sort of complex query, or like until this point at least. Select star from table name where a specific condition is met. You could have multiple conditions, so you could be like where user ID equal to something and email equal to whatever, or a bunch of constraints. So these queries can get more and more complex. For our use case, it's fairly straightforward. Eventually you will see we don't have to worry about writing this because we will be using ORMs, which abstract all of this out. But for now, since we're learning SQL, we will have to learn how to write SQL queries, which is what we're doing right now. Let's do a poll and see if we're going too fast or if we're good to proceed. Let's keep it at 85%. And if 85% are good, we will proceed. Oh. All right. थोड़ा सा yes और दे देते यार. So we're at 83%, which means I'll take a quick pause and I would love to know what's up with the 17%. Everyone else can thoda look ahead and fiddle with these queries. SQL injection, don't worry about. Slightly high level. Feel free to read later on. Not something you need to know at this moment. How are you linking values with array? That's a good question. So it's simple. Okay, if there are, let's look at the create data. Create insert data. There you go. So it's basically, this is the first argument, this is the second argument, this is the third argument, this is the fourth argument. This is just SQL syntax, and these are the values. Okay, whatever is the first value here will be put in $1. Whatever is the second value here will be put in $2, so on and so forth. So these $1, $2, $4 is like a way SQL lets you give the query and the values separately. And that's what we say, okay, bhaiya, why do you have to write 1, 2, 3, 4 here, Harkirat? Because it might happen you have something like this. $1, 2, 4, 3, 4, and then 1 again. For some reason, let's see, you have to put the same thing in two places. That's why you have to explicitly mention which argument are you using here, which argument are you using here. Then just give the arguments in the same order and you're good to go. That's what these $1, $2s mean. Select star $1. Can you repeat what $1 is? Yes, exactly. So this is to prevent SQL injection, what is it is, go back to the video after the recordings where I've explained this, but to prevent it, you can totally do this. Buy groceries and like replace all of these. You can do that. There is a reason that it is done this way. What is the reason? Don't worry about. The syntax is, okay, $1, $2, $3, $4 are the 4 values basically that need to be put. Where does SQL get them from? The second argument, which is this. That is why whenever we're sending a query, we're sending two things: the raw textual query and the specific values. And in this array, value 1 is what represents $1 here, or what $1 will be replaced with, $2, so on and so forth. So that's the high level of why you need the dollars. All right. So hopefully that's clear. It's same can work for like get queries, delete queries, so on and so forth. Let me do a poll again. Alrighty, good to go, above 90%. Let's proceed. No breaks today, guys, because you will have a break at like 7 India time, basically half an hour early, because we have to call it a little early today because I have a flight to catch. Updates. We have done gets, we have done posts. Third thing is you need to be able to update data. Look at this query. What does it look like? Update the table, set whatever field you want to be set with this thing. You can add a comma here and replace multiple values if need be. Set done equal to 1, title equal to 2 if you want to replace values. But in our case, we just want the to-do needs to be done. The user needs to set, this to-do has been done. So update to-dos set done equal to $1, which is like the first argument, false, or it should be true. Ideally, this should be true. So this is incorrect. You should set this to true. And where ID equal to $2, the specific to-do you want to update. So eventually, when you have your website for this to-do application, the user will see all their to-dos, to-do 1, to-do 2, to-do 3. They can click on a button called done. When they do, a backend request will go. This function will eventually be called for this to-do ID, call update to-dos set done equal to true, whatever, should be true, false, whatever, where ID equal to this specific to-do ID, and then you simply do client.query, send it the textual query, send it the arguments, which is in this case false, and the ID, and you're good to go. Hopefully this is also straightforward. Let me show you this in the code. Update data.ts. Let's run yarn build here, and then node disk/update data.js. It says to do with ID 1 updated to done. As you can see, I am sending true here. And if I go to PSQL, I will be able to see that this specific to-do, the to-do with ID, whatever, 1 has been updated to, the done value over there has been set to true. All right. This is how you update data. Again, these queries get more and more complex. Set done equal to 1, title equal to $2, where ID equal to $3, and then you can add a new title here. So these queries tend to grow. In our use case, it's not too complicated for right now. So this is how it looks like. All right. That's update for you. And lastly, there is delete. Our use case does not have we don't have a delete use case in our to-do application. You could. So the user, once they see all the to-dos, they also see a delete button maybe. When they click on the delete button, this is the query that runs. Delete from the name of the table, which is to-dos, where your specific where condition. So if we want to delete a specific to-do with a given to-do ID, after you get the client, run this query, delete from to-dos where ID equal to $1. And then in our case, $1 is the argument that came. That's how you delete. Again, you can totally run it here as well if you need to. If I go to PSQL and let's look at what our database looks like right now. I'm sure a bunch of people have done a bunch of things, so this might have a few things. Select star from to-dos. So it has a bunch of to-dos. There's a to-do with ID 1. Delete from to do's where id equal to 1 semicolon, and it says delete 1, which means one thing was deleted. If I now do select star, I only see 3 to do's. So that's the high level of what delete lets you do. In the real world, you usually never delete data. You add another field here called deleted and you set it to true. You never actually delete data. Deletes are never usually used in production ever at all, because you always want to preserve data, have like an audit log. So delete is usually not very useful, but good to know that you can delete data from SQL databases if need be. All right. Going to exit, going to do a poll before we proceed to, okay, maybe one last thing, which is drop, which you guys already, I think I showed you. It lets you completely remove the database, which means if I run this, I have to rerun the create table command to sort of recreate the table schema in Postgres. This will delete all the data. This will also delete the schema, will delete everything. So drop table if exists. What were the tables that people had created? Oh, sorry. Let's just look at it. Delete. Oh, I don't have a file for this. You don't need to. In the real world, you will never have either the create table queries or the delete table queries in like Node.js. You will run them raw on the SQL database using PSQL. Let me quickly just show you that this actually works, and then we will proceed. Again, I'm running it here. You can totally run it from the PG client here as well. All right. These are the tables that people have created, a bunch of them. Let me just delete one of this, whoever, I do apologize, whoever this is. Maybe I'll delete this one, OMNS users, drop table, OMNS users, semicolon, and then that specific table has been deleted. I don't see it here anymore. All right. That's how you delete a table, like completely remove it from your SQL database. Alrighty. Reaching the advanced stuff, but before we do, we will do a quick poll, making sure everyone's good. Maybe give like a 2-minute break as well. Very good, very good, very good. 90%, which is great. 91%, beautiful. So hope you guys can run this locally. I also hope you can connect this to the existing to-do application. Again, I'm repeating, this is, you don't usually need to write raw queries. ORMs sort of take all of this complexity away. So you don't have to understand SQL, always good to know it. This is how things were done before sort of ORMs were introduced as a concept. But yeah, in the real world, you don't ever have to worry about learning SQL and being like, where ID equal this, and should I write and here if I need another condition, things like these. They're all like very well. In the end, you get functions like Mongoose. So Mongoose is also sort of an ORM. So it gives you very high level functions like dot get whatever table name to do's, like ORM dot get total table name to do's where whatever ID equal to something, so on and so forth. So your life becomes easier eventually, but always good to know SQL, which is what we're learning today. Learned a bunch of basic things, putting data, getting data, all that jazz. I'm sure you can replace it in your to-do application yourself. 3 mildly advanced things you need to know. First one we already knew, sort of foreign keys, joins and indexes. So joins is the most difficult one, the one I want to spend most of my time on. Indexes is depends on how deep you want to go into it. They can be difficult to understand, and like you can spend time there. You don't usually have to. You just need to know this thing does this. And foreign keys are something we've already discussed. I'm going to discuss a little bit more. All right, 3 advanced concepts, then we're good to go for today. And then some disadvantages of this PG library that we're using and why ORMs are needed. And then tomorrow we will discuss our only ORM we need for this open source sort of cohort, which is Prisma. All right. How to relate data, how to join data. As I said, in NoSQL, shove everything for a user in the same database. SQL, that does not work. You need to have separate databases and somehow they need to be connected. This, for example, is our to-dos database, which is, these are the to-dos, these are the users. Each to-do has a user ID field, which relates to, or which is what's called a foreign key to something in the users table. These constraints are this line, user ID integer, references user ID, makes it extremely strict, which means you cannot be like, one second. Yeah, you cannot be like user ID 20 when the user 20 does not exist. And if this user with ID 1 already has some to-dos, you cannot simply delete this user. When you try to delete it, if you run the delete command, it will complain, it will say to-dos already exist. Either delete them, or you can do something called cascade deletes, which means delete this as well as delete all the to-dos and all the data for this user. So that's how integrity of the data is always maintained at the database level. You can do all of this at the application level. For example, someone said, Harkirat, you're saying MongoDB has no schema, but when we defined it, we created the models, right? We created this file which had a bunch of things like what the data should look like. So aren't we restricting data somewhere, or aren't we making it sort of strict? Why are you saying that the data is not strict? And the answer is, okay, I do agree. We do create, for example, these models. Oh, this is front end. Let's see if we can find something. Sorry, I'm going a few. There you go, database. Someone said, okay, Harkirat, in MongoDB also, if you remember, we had created these schemas. Ki haan, user has username, password. But these schemas are not at the MongoDB level. They are at the Node.js level. So if you try to do a whatever admin schema.put username, password and some random third field, it will be stopped here. Sure, I agree. But you can still send raw queries to your MongoDB somehow from other methods, or you don't have to always define the schema. In Mongoose as well, you can have a schema less sort of structure here and send queries to MongoDB. It's not enforced at MongoDB. Ki, haan, these are the 2 things that need to be put here. You could put 10 things here and it will still work. MongoDB is very schemaless. It will let you change data and put anything there. These constraints that we're putting are sort of at the database level, and even if you're able to send raw queries, you can do application level checks, which means in your Node.js process you can check that nothing extra is going, nothing dumb is going. But even if somehow an SQL query reaches your server itself will sort of complain. Your server itself knows that this is a constraint that needs to be followed. There are a few ones, like unique is one. For example, in our users table we said email is unique, and when I try to do an insert, if an email already exists, it will begin to complain. So these all constraints are put on at the database level. And the one that we are sort of worried about in this slide is references, this thing, which means a foreign key to another table. And this is how you, what is called join data across tables. You join data between multiple tables. All right. This is foreign keys. What are joins is the bigger question. So if I give you a question, get me the email of the user and their to-dos. Given a user ID, get me their email, get me all the to-dos that they have. Will you run something like this, or will you run something else? No bounty, but opening the chat. Do you think this is the right way to do it? So look at this. What does it say? Send one query to get the users. Send another query to get their to-dos, and then log them here. In a real world application, you would return it or whatever. But is there a better way to do this that you guys know of? Don't write joins just because join them. All right. Yes. Someone said yes. Someone said no. Okay, very good. Yeah. A lot of people basically said joins. So this is totally a way to do it. You can totally not worry about joins ever in your SQL journey, and you will be fine. But joins do 2 things. One, they make queries faster if you're doing joins the right way. And 2, they sort of decrease the number of database calls that you're doing. For example, here I'm doing one call to the database when I do a client.query, getting all the users. Here I'm doing another call, which means I'm sending 2 different SQL queries separately. So there are 2 round trips that are happening to the database. Secondly, once I get this data, I sort of somehow relate this. Right now it's simple data, user details, to-do details. So even if they're separately returned, it's fine. In the future, it could be some complicated query. Give me all the users in Japan and their addresses with their mother's name and their mother's address. That's how the query becomes very complicated over there. So if I tell you, give me the details of a user, their address, their mother's name and their mother's address, what will you do? Send 4 queries. Give me this user's details. Give me this user's address. From this details, I got their mother's name. Give me this user's mother's details. Then the user's mother's sort of addresses. That's 4 queries. That's where you need to sort of the power of joins kick in. Okay, you can send a single query. Okay, give me all of this for this user. The database sort of what's called joins them and returns you the joined data. So that's what joins are. Given you have relationships between databases, how can you tell to the database, bro, give me all this data, not like individual bits of it in different queries. In a single query, give me all this data. What is the problem that we are solving? Give me the email of the user and all of their to-dos given their user ID. This is the easy way to do it. this is the joined way to do it. Sorry, let's just come to it. But like this one to show, this is what a join means. On this field, these two tables are sort of connected. This is the, oh sorry, I have no slide for this. So this is the easy way to do it without joins. This is the hard way to do it. If you go to the joins folder here, there is advanced -1 here. And let's look at the query. This is might feel a little weird to a few people. Select users.star, which means everything from the users table, and todos.title, todos.description, todos.done. Okay, a bunch of commas here. So firstly, two new things have happened here. Until now we were doing select star from something. Here I'm doing select users.star and todos something else. So we could totally do before select email, password from users before as well, versus doing select star. So that part isn't new. What's new is you're able to get from two different databases, two different tables. Select from users everything, from to-dos just the title, description and done. From, this is the slightly different part, from users left join to-dos. So this isn't from users, this is from users left join to-dos. What is left join? What is join? Maybe just make it join for now. This won't work, may or may not work. We'll see. Won't work actually. Let's keep it left join. Select these fields from users and to-dos. Think of left join for now just as and. But there is another thing here called on users.id equal to todos.users.id. So again, let's try to understand this statement well. Select from what? From to-dos as well as users. So from both of these, somehow joined. What is joined? We'll see. All of these fields on this equal to this, which means a single row finally that this query returns will have whatever email, password, title, description, and done. Every row that this query returns will return all of this. And how will this data be joined? It will be joined on this constraint. So if there is a user with ID 1, we will find all their to-dos and create all of these rows for them. If there's a user for ID 2, we will find all the to-dos and return, sort of create a row for each of them. So if there was, let's say we have two users with user ID 1 and 2, and let's say user 1 has 3 to-dos and user 2 has 2 to-dos, the final result will have 5 rows, with the first row being user 1, to do 1, second row being user 1, to do 2, third row being user 1, to do 3, and then fourth row being user 2 and their to do 1, or maybe to do number 4 overall, and then user 2 with their to do 2, or like user to do 5 number overall. So this query, given such a database, will return these many rows. Is this part already clear, or should we dive a little bit deeper into this? Is this part clear? Okay, this is how joins work, and we're able to join data across two tables. Oh, okay, not bad, not bad. 80%, 75. All right. So I will repeat this part again and maybe give a better example here. Let's say there is user 1. Let's say there's user 1 who has email harkirat@gmail.com, password 123456. User 2 email raman@gmail.com, password 12345. All right. Let's say our individual users table has these two entries, and this guy has ID 1, this guy has ID 2. Our to-do table looks something like this. To-do 1 is for user ID 1, which is Harkirat, title whatever, go to gym, and description, go to gym, and then false for done. And then there is another entry for user 1 again, which is again when we go to gym 1, false, and then 2 entries for, maybe just 1 entry for user 2, which is Raman. Let's say you are the let's say you are Raman and you need to know all of your to-dos and your email in a single query. So you only know your ID, or more specifically your cookie or JWT header. You will send a backend request, give me all my to-dos and my user email. We could on the backend either run the basic query, which was this, get his user query response, get his to-dos response and return them separately. Or we can be like, I want to send this in a single command and get, in this case, Raman has a single sort of entry in this table. So I want a single row from SQL, which has Raman's user ID, which is 2, Raman's username, which is whatever, raman@gmail.com, his password 12345, and the title description of their to do. All right. So how do I send a single query for that? And this is the answer for it. From users, select everything. From to-dos, select, you could also be like select everything here. Only there will be a conflict because ID exists in both of them, which is why you have to separately define to-dos say only give me these 3 things. From users also, ideally you should just have the email and that's it. You shouldn't ever get their password. So this is a better query, but we will stick to this for now. Select this from both of these tables, joined it together. What does left mean? We will come to very soon. On users.id equal to this thing, which means this is sort of the important thing to understand. Okay, you have to be like who, and there's also where here. Okay, where user ID is 1, which is for Raman's ID. Do a join of these 2 tables, which means sort of bring them together on this constraint. Okay, if there's a user ID 1 here, the to-do's user ID is also 1. You got a new row. User ID 1, to-do has also a user ID 1, you got another row. That's how you construct the response for this joined query. You tell that to SQL. Okay, bhai, join these 2 tables, users and to-dos. When you join them on this constraint, which means for all the users who follow this constraint, which means have user ID 1, find a corresponding row in to-dos with user ID the same, and then join them, put them in the response, do it again, so on and so forth. So effectively what this is doing is firstly going over your table, finding Raman, this is the user with ID 2, then going over the to-dos table, then finding, I found a row over there, I put it in the final response. I found another row there, I put it in the final response, so on and so forth. That's how you create a joined query. Is it clear now what a join does? Left join, we will get to things, these things we'll discuss very soon, but like just joins are, very good. 92% is great. So now one thing to answer is what is left join, Harkirat? So if you look at the question here, it was get all the to-dos for a given user. This needs to ensure that every user comes at least once. What that means is you could have a user who has no to-dos. Raman could be a lazy person and he doesn't have any entry in the to-dos table. If I do a join, what does the join say? Okay, for every user, find a row there, put it here. Another user, find a row there, put it here. What if there is a user, but there is no row in the to-dos table? That user will never come in the final response unless I do this thing called a left join. So let's try to understand the types of joins now. There are like 4 high-level types, but why are they needed? Because a bunch of times you have to join tables, but if there is no entry in the other table, you still need to return something. If the high-level query is give me the metadata of the user and all of their to-dos, and you do a raw join, what will happen is since there are no to-dos for a user, there will be zero rows that will be returned, which is why you need a left join, which means if there are no rows, at least return one row which has his name, which is Raman, his email, his password, and like null for all things like title, description, or whatever. If you write left join here and there are no rows in to do for Raman, it will return at least one row with these things set as null. If you don't do this left join, then it will return nothing unless Raman has some to-dos there. If they have one to-do there, then it's fine. Then it will return whatever one row. If they have 2 to-dos there, it will return 2 rows. If they have no to-dos there, it will return 0 rows unless you do left join. That's why you need these types of joins. So let's try to understand the 4 high-level types. One, we just understood the left join, but this is the higher level of the 4 types of join. Full join, or like simply join if you write, it means it should be present in either of the tables, which means if it's present here or if it's present here, you're fine. Inner join, one of वही मैं कहूँ, ये गलत है शायद. Full join is, I think it should be present in both the tables. Inner join is, it should be present in either of the tables, or it could be vice versa. So let's Google that. both the tables. So inner join is both the tables. Both the tables. Full join is should be present in either of the tables. Left join is should have all the entries at least from the left table, which is why what is our left table? It is users. If I do a left join, it will have all the entries from the left table, even if there is no entry in the right table for that specific user. And finally, right join is like the opposite of it. So let's maybe see this in action. What does our users table look like right now? Select star from users. It has, please give me bounty, om@gmail, something and something. So let's maybe take the user ID with ID 1 and then select star from to-dos. There is one to-do for user with ID 2, no to-dos for user with ID 1. All right. So let's try to run this for user with ID 1 who has no to-dos right now. So yarn build node dist slash advanced, joins slash advanced dash 1.js. And as you can see, it still gave me a single row with no title, no description, no done, because there are no to-dos for this user. Let me pull this up a little. So this is the command that I ran, and this is the response that I got with title null, description null, done null. If I make this join, let's see what happens. Most probably it should return still everything because, oh no, it is the opposite then. Full join should be present in either of the tables. Yes. So we did a full join, and if it was present in, oh no, confused. Let's do all of them and then let's see which one of this is. Let's do inner join, still get empty. Let's do full join. Oh, sorry. We do get something. So this is correct basically. If you do a full join, it should be present in either of the tables. We did a full join and it is present only in one table. Still we got the full row. If you do inner join, what does inner join say? Should be present in both of the tables. However, in our case, the user with user ID 1 has an entry in the users table, does not have an entry in the to-dos table, which is why if I run this, I get no rows from the backend. Left join says everything from the users table. Even if they don't have an entry on the other side, it is fine. If they have an entry here, it will be returned, which is why if I run this, sorry, need to build first. I get it here. What is right? It is the opposite of it. So if I do a right join, it should ideally not return me everything because we don't have an entry on the right side and it doesn't return me anything. All right. So hope this is clear. The 4 types of joins. One question I have right at this point is what is join by default? And I think the answer is it inner? Yeah. So by default, if you write just join, it is the same as writing inner join. Join and inner join are the same thing, which is why I got confused in the beginning. Again, just to recap, what is joining? Joining is when you join 2, 3 multiple databases. This is just one that we saw. You can actually join a few sort of tables here. Like I think the syntax looks something like this. Join this and then join, let's say, another table, whatever, I don't know, address on whatever. I think so. Like the syntax looks something like this. It could be something else. But yeah, you can join on multiple tables. If you want a user and their address details and all of their to-dos, you will be joining across 3 tables. Only the syntax sort of changes on what constraints are you joining and what is being returned. And again, the other important thing to know is the 4 types of joins. Most of the times you will be using left join because you do want all the entries from the left side of the table usually, which is like the primary thing that you're querying. If you're querying for users and their to-dos, what you really worry about is users, and you need to get all the users. Even if they don't have a to-do, it's fine. You still need their user details, which is why left join is sort of important. Like the thing that's usually used, but really depends on the query. For example, I have advanced 2 here where it says get all the to-dos for a given user. So given a user, get all the to-dos. This shouldn't return a row if no to-do exists for the user. So what should be the answer here? It should just be inner join or join, which is like the same thing. So that makes sense. So in our case, the user with ID 1 has no entries, which is why it returns an empty thing, which is what we expect. This guy said get all the to-dos for a given user. This shouldn't return a row if no to-dos exist for the user. Advanced one was slightly opposite. You get all the to-dos for a user and the details of the user, but if the thing does not exist, do return me something for the user. This guy is like, if there is no to-do for the user, you don't have to return the details to me as well. This doesn't sound like a practical use case. Usually you do want all the users metadata, and to-dos are like fine. Even if they don't exist, it's fine. Lastly, what is this? Yeah, so another sort of important sort of a query that requires join and might be needed for an application like this might be get all to-dos with users details. Let's say there's an admin, they want to see all the users and all the to-dos. So again, you could do two queries to get all the users, get all the to-dos, or you could do a very long single query, select everything from to-dos, and from the users table, maybe just their email and their password. You can also like maybe get their ID, but like ID will conflict here and here. So you can just rename this like user ID as something else. I don't know the exact syntax, but I'm sure there's a way. I mean, I know there is a way, but I'm not sure of the syntax. Okay, you might require this thing as user ID. Even if there are like conflicting keys here, you can somehow sort of get both in your single query. And then again, just from to-dos, join users on to-do.user ID equal to user.id. This gives you all the to-dos. So again, over here, on the thing on the left is to-dos, because we need all the to-dos. And then if there is an entry for the user, it's fine. If there is no entry, you don't need that specific user in your final table, because what are we worried about? We're worried about all the to-dos and the associated metadata. We don't, if there is there will never be, there can be users who don't have to-dos, which is fine. We don't want to see them in the final row. We want to see, if there are 20 to-dos, we want to see finally 20 rows with their user metadata attached on every row, which is what this query will do. All right, let's do a poll before we, oh shoot, I'm running low on time today. Okay, cool, pretty cool. 95% is great. Lastly, indexes. So maybe I'll cover this tomorrow, but this is the syntax to create what's called an index. What does an index do? It makes queries faster when you're trying to run a query on a specific, let's cover this tomorrow because it's sort of important. And finally, what are the problems with this? One, you need to know SQL. That's not great. You have to be an SQL engineer, and it's very hard to remember, as I was trying to remember, okay, what's the syntax for SQL? So it's always good if a library comes and abstracts all of this. That's what an ORM is. That's what we'll discuss tomorrow. Secondly, migrations are hard, which means like you have to maintain in your head, okay, these are my tables, these are what they look like. And if in the future it changes, you add like a new table there, a new entry, let's say to the users table, that becomes slightly harder. And you don't get the best types. I know that I get back a response from here. I don't know what the type of rest.rows is. So I cannot do like rest.rows.id. I don't get very good typing here. But if you use ORMs, they sort of give you very nice types. That's why you sort of, another benefit to use ORMs. That's what we will discuss tomorrow, which is like the Prisma ORM. There are a bunch of others. That's the one that's most popularly used today. That's what we'll discuss tomorrow. I'm going to open chat just for 5 minutes and then I'll have to call it here because I have a flight to catch in 3 hours. But any questions? What is insert into returning ID? That's inserting into the database. And I think, returning IDs. Okay, if you want, so as I said initially, so if you go back to the video, I basically discussed this, but it was basically, if you insert data, you don't know what the user's ID is initially, right? That's sequentially increased by SQL itself. So it's a good idea to get it back. And then if you want to use it here, you can. So you can, as you can see, we used it somewhere here. Response.rows0.id. You can also be like returning star and you'll get all the rows. But like the returning bit is sort of necessary because ID is something that's generated by the database. So it's good to have access to it here so that you can use it in other places. That's what returning does. All right. Is this much SQL enough for interviews? So interviews will specifically go so into depths of, how are indexes created? How is it? So for interviews, practically when you're creating applications, this is more than enough. Interviews ka point is to get your depth of knowledge. So there they'll ask you 10 different things. They're like standard interview questions to know, not usually used in the industry. Like unless you face an issue, database becomes very slow. You don't really worry about these things on day 0. What is the learning of Prisma? It's okay only. It's very well abstracted. It's like Mongoose only. There are a few extra things like migrations, but like at a high level, not too difficult. All right. Prince, क्या पूछा? Cover advanced TS3 again. You mean advanced TypeScript? We will have a class which will cover some things, but like not too much. How to find different contribute companies? So start with one. Start with dub.sh. Start contributing. At least set up the code locally. Make sure you understand everything. Then there's step 2. So I think the step is to just to start and start to contribute. All right, going to pause here. So all the questions I'll be able to take today. Use alias to in joins. I think some people don't know about them and it will help them for sure. Okay, I will cover this tomorrow. Aliases in joins. Is this much SQL? Okay, so kar diya tha. All right. Question not related to the class. How can we use TSOA in Turbo Repo? Oof. If you have an Express backend, it will just work. You have another module where you use TSOA. If you're using, the bigger question to ask is can you use TSOA in Next? And I think the answer is no. So Next might have some other library that lets you do auto-generated OpenAI API types. But I don't think TSOA generally works with the Next backend, although Next also internally uses Express. So there might be a way to, put it as an adapter, but I don't think there's an easy way to put TSOA in Next.js. In Turbo Repo, you can, as long as you're using an Express backend. T3 stack, most probably might not be covering the whole thing. We will cover TRPC and what's the other things in there. Maybe there's some things that get missed, but at a high level, we'll try to cover most of the things in the T3 stack. So the reason we're covering Prisma is because everywhere Prisma is being used. Cal.com is using Prisma, dub.sh is using Prisma, so it's like the popular ORM, which is why we're covering it. Postgres and so SQL queries are the same, but like there is some nuances or like difference between MySQL queries and Postgres queries, and like their internals a little bit, but at a high level, they're very similar. How to make ER diagram? Probably out of the scope of this course, and it's very simple. You just have to create figures, Sequelize versus Prisma. I've only used Sequelize. Prisma I'm now learning to teach, and like every library is using it, but like Sequelize was the popular one. I don't know, a bunch of these libraries suddenly come, everyone starts to use it and like they become the norm. But like up until a year ago, like Sequelize was the only thing, and like now it's Prisma. So yeah, Sequelize again, one is easy. If you know, Prisma is like slightly harder because you have to create types. It sort of handles your migrations, database migrations, lets you easily switch between databases. I guess Sequelize lets you do that as well. But like at a high level, if you know Prisma, I think it should be very easy for you to know Sequelize. I don't think the opposite is true. All right, sorry guys, I have to call it here. We can do a longer class tomorrow. Hopefully we do a class tomorrow. I have a flight right now, but I should reach India by 5, and then I'll see you guys tomorrow in tomorrow's class. I'm glad I was able to cover the whole thing. Hope you guys have a good Saturday evening, and I'll see you guys in the next one. Bye. Cool. All right. Stop share. End for all.